Hi everyone, in this video we're going to continue talking about the real zeros of a polynomial function. We've talked quite a bit about it so far in the previous videos, so now we're on the step where we're going to be using the theorem for bounds on zeros. So here's our theorem, and this is to tell if you have what's called an upper bound on your list of zeros or a lower bound. So you can read through this, but let me just kind of summarize what's being said here. So if we have a positive number, so if you have some number, they're calling it m here. So if you have some positive number m, and when you do synthetic division by dividing by the factor that has m in it, so x minus m, and when you do that division, the third row of your division, which is going to be down here, so you put m up here in the corner, and then you put your coefficients from your polynomial here, and you do your synthetic division. The third row down here, if the signs on those numbers are all positive or they happen to be zero, so if you see all positive numbers or zero, then we call that number m, we call that an upper bound, meaning that there's nothing above it. It's bounding our list. So if we have a list of numbers, a list of rational zeros, or possible rational zeros, let's just say this is our list. We're going to make it up really quick. Let's say we have a list like this and like that. So if I have my number m, let me add that into the list, okay, and there's more numbers after this, then that as an upper bound means that nothing above it is going to be one of your zeros. So you can actually minimize your list. You can cut it off with that upper bound if you know that that's true, and you can tell if that's an upper bound from the third row of your synthetic division. Very similarly, for a lower bound, you have a lower bound if the third row of your synthetic division, if this number is negative to start with, and your third row of your synthetic division is going to have alternating signs. Okay, so the signs switch from negative to positive or positive to negative, or they're zero. Okay, so if that's how the third row looks after you do your synthetic division, then that number is called a lower bound, meaning that if I put numbers on my list, let me modify my list up here really quick, and say that your list had little m on it somewhere, okay, like that, then anything lower than that doesn't count. We don't need it anymore because that is the lower bound, meaning nothing is lower than it. So you can cut those numbers off of your list and then just focus on what's remaining to find your zeros of your polynomial. Okay, so let's do an actual example. For this polynomial function, let's use a theorem we just learned about to find an upper and lower bound to our zeros. Alright, so here is our list of possible rational zeros, and a quick reminder, because we've done this in the previous videos, how to find this list is you take the factors of the constant term. In this case, it's negative 36 from right here, and you divide those by the factors of the leading coefficient. And in this polynomial, that is invisible 1 right here. So that's how you find this list. And then what we're looking for is using the upper and lower bounds theorem, if we can minimize this list, because right now if I expand this has 18 numbers on it if I write it out with all the negatives and then all the positives. And so it would be really useful to not have to check so many numbers for finding the actual zeros. So if I can find an upper and lower bound, that would help a lot with minimizing how many numbers I can actually have to work with. Okay, so when it comes to finding the upper bound, what you want to do is to just be systematic, is start with the smallest positive number from your list, and then if that doesn't happen to be an upper bound, then you just go to the next number. So for us, we're going to start with 1 and then check 2 and so on, and until we hopefully find an upper bound to our list. Then same thing with the lower bound, you start with the largest negative number, and then if that doesn't work, then you start picking the other negative numbers after that. Okay, so in the next slide, we're going to summarize the results of doing synthetic division with numbers from our list, and just showing the third row of the synthetic division. So I'll work that out with you so you understand what's happening here. Okay, so let me remind you of a few things. Our polynomial was x to the 4th minus 5x squared minus 36, and right here on the left of this table is some of our possible rational zeros. And so we want to start with the first positive number, 1, and then the way the synthetic division goes is you take your coefficients from your polynomial. So invisible 1, x to the 4th, 0, x cubed, negative 5, x squared, 0x, and negative 36. So you want to put zeros as placeholders if you have any missing terms. And then what we're interested in is this third row down here. Okay, so let's go through the synthetic division on this one real quick to remind you how this goes. So you have to just bring down your first number, and then you start multiplying. So 1 times 1 goes here, and then you add. So you say 0 plus 1, and then you multiply. 1 times 1 goes here, and then you add. Negative 5 plus 1 is negative 4. Then you multiply. 1 times negative 4 goes here, add those, you're going to get negative 4. And then last one, 1 times negative 4 is negative 4. Add those and we're going to get negative 40. And so a couple of things. One is that this is not going to be one of our zeros because the remainder is not 0. So anytime this last number is not 0, then the factor doesn't go into our polynomial evenly, and that number is not a 0. Okay, so we know right away this is not a 0. But the other thing is this an upper bound? And so we have the third row. Notice our third row of our synthetic division is here. And what we're looking for with positive numbers, the positive possible real 0 is if this third row is all positive or 0. And notice this is not all positive or 0. We have some positive numbers and some negative. So this is not an upper bound. All right, let me rewrite the list for us so I can kind of clarify what this means. Okay, so what this means so far is if we look at our list of possible rational zeros and we look at just the positive numbers, so if I split my list right here, 1, we just figured out it is not a 0 of our polynomial, so we can cross it off the list. It also is not an upper bound, so that's all we know so far. If we repeat this process for the next number 2, and so the third row is not all positive or 0, so that one's also not an upper bound. The remainder wasn't 0, so it's also not a 0, so let's cross that off. But then when you look at 3, when you plug in 3 into your synthetic division, divide by that factor, look at the third row. Everything was positive, and so that one is an upper bound, meaning that anything bigger than 3, we don't need it. So we get to take our list and cross off all these other numbers bigger than 3 because 3 is an upper bound of our list. It's like a ceiling, and nothing goes past it. And so that's good news. We don't have to check any of those other numbers. It also happened to be a 0. That's just a coincidence that the remainder was 0 here. It's an upper bound and a 0. So, but what I'm trying to teach you all here is that it was an upper bound. It just is nice that it happened to be a 0 as well. Okay, and so now let's try the same thing with some negative numbers. So if you do your division with negative numbers and you look at the third row, if you take a look at what happens with negative 3, the signs alternate. So remember the theorem, the upper and lower bounds theorem. It's an upper bound. So it was an upper bound if the third row had positive numbers only or 0. And if it is a lower bound, so it was a lower bound if the third row had alternating signs. Alternating signs. Or 0. 0 gets to be on the list in both cases. So if it was a positive number that we plugged in using our synthetic division and the third row was positive or 0, then it's upper bound. If it's a negative number that we check and the third row has alternating signs, then it's a lower bound. So if you check negative 3 using synthetic division, because this is positive, negative, negative, this one is going to be a lower bound. So what happens on our list of numbers is you can cross off everything smaller than negative 3. So it just also so happened that this was a 0 of our polynomial. Another coincidence, but it means you don't have to check any other numbers less than negative 3 because it's a lower bound to our list. So you get to cross off all those numbers off the list. All right, and so the last thing to mention for this is just what I was saying, that this just so happens to be the zeros of this polynomial. So if you were to solve this polynomial equation, there was only two real answers, two real numbers. X is 3 and x is -3. That is just a coincidence that those were also our upper and lower bounds, just so you are aware of that. But those are the answers to that equation. Okay, so that is it for this one, and then the very next one we'll talk about the intermediate value theorem.